Hello and welcome to 2.6. This is about composition, so how we put functions together. It's all the operations with them, add, subtract, multiply, divide, and then actual composition itself. And we'll work, a little bit about domain. So make sure you have 2.6 notes in front of you, and let's go. All right, when you look here, we have f of x, which is x squared minus 49. When worried about domain, that means you can't divide by 0, correct? So all we do is we take the x squared, or the denominator, you don't even look at the numerator, and you set it equal to 0. So we take x squared minus 49, set it equal to 0, add, square root, and x cannot be equal to plus or minus 7. We can write it this way, or we can write it in interval notation. So that just means if you're on a number line, negative 7 to 7, so you would go from negative infinity, to negative 7, parenthesis, and then from 7, negative 7 to 7, parenthesis, so it can't include negative 7, and then from positive 7 to positive infinity, using your union symbols, and that's interval notation. Okay, pause and try yours. So you should have set the denominator equal to 0, so you got x cannot be equal to 9, which is your domain, written in interval notation. You said, okay, I can go from negative infinity to 9. I cannot include 9. And then I can start on the other side of 9 and go to positive infinity. And there's your domain. So we worry about the denominators, correct? Or square roots or absolute values, things on that order. Okay, now we have sum, difference, product, and quotient. This just means you take both functions and you add them together. This means you subtract them, multiply, or divide. Divide, you have to be careful because the g of x is your domain. So when you're using division, you will check the g of x and see where it cannot be equal to 0. So let's go here. We are adding, we're going to use these same functions all the way through. So f plus g, so I'm going to take x minus 1 plus x squared minus 1. So I'm taking the f of x. You don't have to write this in your homework. Plus the g of x. You do have to write the next line though. So I'm going to take the x minus 1 plus the x squared minus 1. I'm not dividing, so my domain is negative infinity to infinity. Put these in descending order, please. So you have x squared plus x minus 2. Okay, try the next three. So now when you subtracted, you should have taken the x minus 1. I hope you were very careful here because this is minus the quantity x squared minus 1, which really means x minus 1 minus x squared plus 1. Again, your domain is negative infinity to infinity. Should be a parenthesis there. The ones are going to cancel, descending order, negative x squared plus x. Did you do a good job? All right, now you're going to multiply. So we're going to take the f of x, which is the x minus 1, times the g of x, which is the x squared plus 1. Distribute. You've got x cubed plus x, so here to here, minus x squared minus 1, descending order, x cubed minus x squared plus x minus 1, x cubed. So you know that this shape looks like this, correct? Domain again, there are no restrictions on x, so negative infinity to infinity. Okay, here we go. We have our division finally. So now we're going to take the g of x, so it's the division, so it's the f that's going to give us our domain this time. So it's x squared plus 1 divided by x minus 1. I know I cannot divide by 0, so I have to set this one equal to 0. So x cannot be equal to 1. This is my domain. Anything but x equals 1 so far. So now we're going to factor that top, which does not factor. So we are done right there. Should have made that an x squared minus 1, shouldn't have I? I didn't mess that up, did I? I think it was to begin with, honestly. Yeah, it was x squared minus 1. All right, sorry I wrote it down wrong. I hope you did better than I did. So this is truly a minus sign here. So we're going to factor that top. So that's x plus 1 over x minus 1 all over x minus 1. Now our numerator denominator cancel. Our final answer is x plus 1, no restrictions, so this is the entire domain. Okay, let's continue on. This is composition. This is read f of g. That little circle is read of. This also means it can be written like this. F of g of x. So what we're doing is we're plugging g of x into all the x's of f. So we're taking the g function and plugging it into the f function. So my f function is x minus 1. So we have f of x. We're going to write this out the long way just so you see it. Now I'm going to take f, I'm going to plug g into f, which means I'm going to take this x out and replace it with x squared plus 1. So this becomes x squared plus 1. This is going in this place of this g substitution, minus 1, which really means x squared. No division here, no restrictions on the domain because x can be anything, so it's negative infinity to infinity. All right, try yours. So now you plug the f into the g. So you said, I'm going to take the x out of the g and replace it with x minus 1. So it's x minus 1 squared plus 1. I would actually let you leave it there. If you wanted to work it out, you could. And then you would just square this, which is x squared minus 2x plus 1 plus your 1 on the end. So you would have ended up with x squared minus 2x plus 2. But this is fine. I'm just checking to see if you can understand functions and composition. Again, no restriction, so your domain is negative infinity to infinity. Okay, a little bit harder. Let's try this here. Pause and give it a shot. So here the g goes into the f. So I'm going to take x squared minus 3 and plug it into this x. So this gives us the square root of x squared minus 3, in for the x, plus 2, which is truly the square root of x squared minus 1. Okay, now let's see if you can do it. You plug the f into the g this time. So now the squared, I'm going to take this x out and plug this in. So this becomes the square root of x plus 2 minus 3. The squares cancel the square root, which is x plus 2 minus 3. So this is x minus 1. How you do with composition? Not too bad, right? Make sure you take your time and remember who goes into who. So next, we're going to worry a little bit about domain right now, because the g of x gives us our domain because that's what we're plugging into f. So what we're plugging in is the domain. Well, that means I have to look at the g of x function and see where it is undefined. So I look at its denominator, which is just x. So it's undefined when x equals 0. So x cannot be equal to 0 because that causes us errors, correct? So now we plug it into our original function. So we take out this x and we plug in the 1 over x. I'm hoping you remembered how to solve that without me. But that is for 1 over x plus 2. Remember, you make everybody a fraction, you get a common denominator. So this guy needs an x in the denominator and the numerator. Denominator, numerator. Denominators are the same, so they cancel, and you end up with 4x over 1 plus 2x right here. But now I must also check again where this numerator is undefined. So we set it equal to 0, and x cannot be equal to negative 1/2. So we have two restrictions, negative 1/2 and 0. So we go from negative infinity to negative 1/2, negative 1/2 to 0, 0 to infinity. Make sure they are all unioned together. All right, try yours. So now you're doing f of g, or g of f. You're using the exact same functions again. So you're up here. This time the f goes into the g. The g is 1 over x. So now the f is our domain. So the denominator of the f is x plus 2. Set that equal to 0. So x is negative 2. So x cannot be negative 2 was our first one. So now I take the f and plug it into the g. So now I have 1 over 4 over x plus 2. All right, I'm hoping you understand that that's just a reciprocal because you got 1 over a fraction, so you flip it. But if not, you would have put the 1 over 1. Common denominator would have been x plus 2. which would have canceled, giving you x plus 2 over 4. There's nothing wrong with this denominator, so this is the only restriction on our domain. It cannot be equal to negative 2. Interval notation, negative infinity to negative 2, union with negative 2 to positive infinity. Good job. All right, here we go. Last but not least is how do you rewrite a function that is a composition into its original functions? First thing you do is you look inside the grouping symbol. Remember, that can be parentheses, it can be brackets, it can be braces, whoops, it can be square roots, it can be absolute value, whatever grouping symbol you have. So my grouping symbol is parentheses, so whatever in there is my first function. So now if I take that out and I replace it with an x, that's my second function, x to the 8th. Try yours. Your grouping symbol was the cube root. So your first function is whatever is under the cube root. Take it out, and that's my second function. So then g of x is the cube root of x. All right, good luck on your homework. Hope you do well.